Everyone. Today we are learning about rotations of polar graphs. I'm going to do my very best to make this go as quickly as possible, but it is kind of a tough topic, so it might take us a little bit. And I apologize if my graphing looks bad on the smartboard here. Okay, so the first thing we're going to do is just practice graphing. So hopefully by now, when you look at something that says r cosine theta, you recognize that this is just a vertical line with x equal to 4. Okay, so hopefully you get that. So that means when you look at the graph of that, you should see this horizontal line. I keep saying horizontal, vertical line at x equals 4. Okay, so now you want to think about taking this r cosine, but not just theta, but theta minus pi over 2 equals 4. And what will that make? So we're going to turn it into rectangular first and then see where that graph ends up. So this is where all of your formulas that we have learned in previous chapters are going to be helpful. So this is a cosine subtraction formula. So if you don't remember these, you might want to go back and review because you're going to need them here. So cosine theta, cosine pi over 2 plus sine theta, sine pi over 2 equals 4. I'm going to distribute the r. And I'm going to change two things here at the same time. The first thing I'm going to change is what cosine of pi over 2 and sine of pi over 2 are equal to. So cosine of pi over 2 we know is equal to 0, so gone. Sine of pi over 2 is equal to 1, and r sine theta, if you remember from earlier in the chapter, is equal to y. So I actually have y equals 4. So I am just graphing now that horizontal line that I have been wanting to talk about so much at y equals 4. So let's make this look nice. Okay, so there's our new line that we changed from polar into rectangular. So keep what we just did there and how that turned in your head as we do the next problem. Okay, so we're going to start by graphing r cosine theta minus pi over 3 equals 4 without changing to rectangular. So we want to see if we can kind of come up what's happening here. So the first thing I'm going to do actually is I am going to graph just r cosine theta equals 4 first. So I'm going to do this first. So again, that's a vertical line at 4. And then I'm going to try and figure out, well, where would this turn? When I do this rotation stuff, I really want to think about the center of my polar grid kind of being like the horn on your steering wheel, and that your hands are going to sit on whatever circle your line or your shape is on. So it's like my hands are on the fourth circle, and I want to rotate this thing or turn this thing. So we want to figure out what direction we're turning. So thinking about what we did in the last problem, I want you to take a guess on where this is going to turn to. So what direction is it going to turn? So while you're thinking about that, I'm going to go ahead and change this to rectangular so that after you have gotten your guess, you'll be able to see if you were right or not. Okay, so I have changed it to rectangular first by using my cosine subtraction formula, knowing off of the unit circle what cosine and sine of pi over 3 are, replacing r cosine and r sine with x and y, Now I've multiplied this whole equation by 2, and now I'm going to go ahead and get this in y equals mx plus b form. So root 3y equals negative x plus 8. So y equals negative root 3 over 3x plus 8 root 3 over 3, or some kind of general version of that. So if you think about what this is going to look like, 8 root 3 over 3, now what's that equal to? I should probably have calculated that out. What is that as a decimal? So that's about 4.6. So that is a little like right up here on the graph. And I have this slope, but the slope is negative and less than 1. So it's kind of going in this direction. So if you can envision taking this line, and let's see if I can get it to turn. I can't. But think of turning it on that circle so that it is now going to, let me get my different color pen here, be tangent to the circle at pi over 3, because that's the distance we are turning it, and then go through this about 4.6 that we have and create a new line. So here we are. So there is this y equals negative root 3 over 3x plus 8 root 3 over 3 as the line. So what can you conclude? Well, I hope that you were able to conclude that on this particular problem, when we rotated it, and then the angle, we had an angle that was then is theta, let's call it theta. So we have theta minus some new angle with the minus sign in there. This created a rotation in the counterclockwise direction. Okay, so counterclockwise being the opposite direction that the clock turns, right? So clock usually kind of goes down to the right. This thing went up to the left. All right, here we go. So the next problem says graph r equals 4 sine theta. So r equals 4 sine theta. I hope that you know what this is. It's actually easier to graph it without changing it to rectangular. This is a circle that is all above the y-axis or the polar axis, and it actually has a center at 0, 2. So I am going to rewrite it. So it would be x squared plus y minus 2 squared, and then a radius of 2, so 2 squared is 4 over here. So here's the equation in rectangular. And we then are going to turn this new problem into rectangular and see what the new graph looks like. So this has been rotated as well. So as I'm working through the problem, kind of take a guess on what you think is going to happen. There is one extra step that we have to do on these problems when we start. So the first thing we need to do, and this is going to be true for all of these, is you're going to multiply the whole equation by r. This is because I need it to be r squared, but I don't want to square this 4 sine theta plus pi over 4. That would be a disaster. So I'm just going to multiply the whole entire equation by r so that now I have this r squared, which I need because I'm creating a circle. Okay, so I'm going to go ahead and use my sine addition formula. So sine theta cosine pi over 4 plus cosine theta sine pi over 4. And I am going to go ahead and distribute the 4r and do cosine of pi over 2 and cosine of pi over 4 and sine of pi over 4 at the same time. So when I do that, I get 2 root 2 r sine theta. If you're not sure where I got those numbers from, pause and think about it, work it through yourself, and put an extra step if necessary. And then this is 2 root 2 r, forgot my r, 2 root 2 r cosine theta. Okay, we know that x or r squared is x squared plus y squared. We know r sine theta is equal to y, so 2 root 2 y. And r cosine theta is x, so 2 root 2 x. This problem is one of the more difficult ones we're doing because of the radicals. So I want to get this so it's a problem that has a setup that looks like a circle. So I'm going to bring the x's and y's to the left and complete the square. So I'm going to save myself a little space here. Okay, so I've subtracted everything from the right side and moved it to the left. Left a little bit of space so I could complete that square. So remember, when you complete the square, you take the middle term, so 2 root 2, divide by 2, so that gives me just the square root of 2, and then square it, that gives me a positive 2. Okay, so this is my answer for this part. Happens to be the same value with the y's. And when you complete the square, you have to add those numbers to the right-hand side as well. Okay, good news is that the radius, or sorry, the radius of 2 didn't change. This 4 here is the same 4 as in the original problem. And this becomes x minus root 2 quantity squared, y minus root 2 quantity squared. So that means the center of our circle is at square root of 2 comma square root of 2, and the radius is at just 2. And so now we want to graph that, and I think I have that already done underneath here. Yes. So the blue circle is that changed graph. So square root of 2, square root of 2 will actually have a center on this center circle. So it will be right, oh, let me get a pen actually. It will be right here, which this happens to be the pi over 4 angle. Okay, so I want you to think about how we started with the red circle and we went to the blue circle. We got this new center and radius, and we can see the new shape is still going through the origin, but it has been turned. Okay, on to number 7. So now it's a similar problem. Okay, so before I change it to rectangular, I want to think about what's going to happen with this problem using the same idea that we had on the last one. I want a new color here. So I'm going to really just think of this being r equals 6 cosine theta. So 6 cosine theta, we know, is just a circle, it's completed there, circle that is symmetric to the polar axis. So it would be like over here where this is 6, okay? So if I were to think about this actual circle, this would have a center at 3, 0. It has a radius of 3, so a 9 over here. So this is this circle here. Now I'm going to turn this circle. So think about what you did on the last problem. When it was plus, we turned it, well, it wasn't plus, it was negative, so we turned it counterclockwise. Now this plus, I hope that you have figured it out, is going to turn it clockwise. So let me get rid of this here. So the purple is the original circle. So original circle, hello. Okay, and the green is the new rotated one. And we rotated it pi over 3 clockwise. So pi over 3 would actually be this line right here. And so the new center is right there. Still has a radius of 3, but the center has turned. So it went from here to there. So if you can figure out what that center is without doing all of the formula stuff, if you can just think, this is a point on the third circle at the 5 pi over 3 spot on my graph, and you can come up with that, that would be awesome. Otherwise, you're going to have to take the problem and do exactly what I did on the last one, which is I'm going to multiply the whole equation by 6. Nope, r, I'm sorry. Multiply by r and use my cosine addition formula. So I'm going to put all the steps here, but I'm not going to explain each of them. I just want you to watch and then work through it. Okay, so this point should be to the right 3/2. So my center is 3/2 down. So -3√3/2. So this is your center, and your radius should be 3. Okay, so all of those things are what you could have gotten by looking at the circle. So maybe you can figure that out. We're going to talk about that on another problem. But otherwise, hopefully you were able to conclude that if, type this part up, you have a problem that has a theta minus an angle, I already did that, theta plus an angle, then this will be a rotation clockwise. Okay, so make sure you're writing that part down because that's probably the biggest piece of the puzzle here. All right, so now we've got this strange problem going on here, and I'm going to walk you through the first general process on this one, and it's going to be the same kind of process for number 10 here. So first thing we're going to do, let's see here, is change the r squared and the r cosine theta into its rectangular pieces. So r squared is x squared plus y squared, and r cosine theta is x. I end up with this. Notice I did not move that 16 over, and hopefully you will remember not to do that as well when you see a problem like this in the future, because this problem actually has already been completed, meaning its square has already been completed by the way it was written out. So the 16 here actually becomes the completed square with the x squared and the 8x. So this is actually x plus 4 squared plus y squared equals 25. So this has a center at -4, 0 and a radius of 5. So this picture is kind of strange because the center is way over here at -4, 0, and the radius actually goes past, well, it goes way off of this grid, but it goes past the origin here. So my graph is going to look terrible. I apologize, but it goes like this. It's supposed to hit that point, right? And goes all the way up and around like that. So it's hitting this point, it's hitting this point. Here's your center. This is a really big circle, not centered at the origin and also not going through the origin. However, the rotation piece is going to be the same. So since I have this theta minus pi over 2, and it's that theta and then the minus the angle, that means this circle that I've drawn there is going to rotate counterclockwise. So this is going to have a counterclockwise rotation, which means it's going to kind of go, so think about which direction the clock is going. It's actually going to go down. It's going to go, again, the opposite of the clock. Okay, but if you're not 100% sure of that, then you can, again, change this new problem to rectangular if you need to. But this circle, again, this center point that's right here is going to move, in this case, 90 degrees. So it's going to move 90 degrees along the circle right here, and it's going to move right down to here. So the center is going to be here. The one part of the circle is going to be there. Another part's going to be way down here, and the circle is going to, it's really hard to draw on this tablet. Whoa, well, as you can see. Okay, so there's my lopsided potato looking circle. Okay, so I'm going to change it quickly into, actually I'm not. I am not going to change it to rectangular by using the formula. Instead, what I'm going to do is literally just write out what the equation should be, because if you can figure out how to rotate it properly, then you won't have to do all that mess with the formula. So the center moved. The radius didn't change though, but the center moved. So this would be what the equation would be. Okay, so these now say to try on your own. So what I'm going to recommend you do is to do just that. Try them on your own and then check with your teacher and use Desmos to check your answers. So after you've attempted them, either ask your teacher if you're in class or use Desmos to graph them and see if you get it right. All right, see ya.